Hello Pre-Calculus kids, we're going to be looking at section 8.4 today on basic trig functions. Kind of a review of things you might have learned in geometry, so hopefully it'll be an easy one for us. But they start out looking at all of these right triangles. By the way, the trig ratios that we're going to be talking today about, the sine, cosine, and tangent, they only work for right triangles. And a right triangle is a triangle that has a right angle in it. So you can see this little box notation that's there for all of these. And that's just telling you got a right triangle. But I'm sure you probably knew that from back in the day of geometry. So, yep, we got right triangles. Everybody got a right triangle. All right. The second thing that you'll notice about all of these triangles is that every single one has an angle of 31 degrees. So you've got the 90-degree angle, you've got the 31-degree angle. Could you figure out what the missing angle is, this other one in all of these triangles? Could we figure that out? And if you remember the rules, again, from geometry, you know that a triangle has the angles of a triangle add up to be 180 degrees. The angles, this is my symbol for angle, you'll see me use that a lot. The angles of a triangle add up to 180 degrees. All right, so that's going to be important to us. If I've used up 31 degrees and 90 degrees, how much is left for the last angle? So you think about that a little bit. And your 180 in your little brains, 180 minus 90 minus 31. So I've got 180 minus 90 is 90. 90 minus 31 is 49. Or is it 59? Oh, jeez. We're going to need calculators today anyway. Grab your calcs while I double check myself here. 90 minus 31. 59. There you go. I knew that wasn't sitting right with me. 59. Phew, can't do basic math, but I can do calculus, right? Okay, so 59 degrees for all of these in each triangle. Then my question for you to think about is, how come all the sides have different angles or different measurements? Like this one, they both have the same 59 degrees and 31 degrees, but this guy goes 58, 30, and 50. By the way, remember this longest side is the hypotenuse. We're going to talk a little bit more about that in a minute. The other two sides are just the legs. They don't have special names. But the longest side, the one that's opposite the right angle, he's your hypotenuse. This one has a hypotenuse of 58. This one, it's 70. This one, it's 64. This one, it's 25. This one, it's 41. So even though they have the same angle measurements, the sides could be all different things. But the one thing that's very important is that these are all similar triangles. If you remember that from geometry, similar triangles, and similar triangles have equal angles and proportional sides. And you say, what does that mean? And I'm going to show you, because we want to figure out what this side is right here. Here's my big old question mark, right? And so I can pick any of the other triangles to use to be able to calculate what that particular side measurement would be. All I need to do, and I'm going to pick the smallest one because he's got the littlest numbers, right? It'll make our math a little bit easier. So if the sides are proportional, which side in this triangle is in the same location as the question mark? And you would say the 15. So I know that I'll keep it this way, question mark over 15, they're in the same location. And now you have a choice. You can either use the hypotenuses, the hypotenuse. I guess you don't have another choice with this one. You've got to use a hypotenuse if you're using this guy, because you don't know what this bottom side is either. So I know that the hypotenuse in my question mark triangle is 70. and my hypotenuse in my little guy is 29. And so the way that I solve that is by cross multiplying that. We've seen that in other sections that we've done together. So I take, you want to call this x, just to make our math easier. 29 times x equals 15 times 70. So I go to my calculator and I look at what that might be. So if I do the 15 times 70 first. 15 times 70. That gives me 1050. So now I got 29x equals 1050. And then to figure out what x is, my question mark, I have to divide them. So 1050 divided by 29. And I get 36.2. And that's my answer. All right, so similar triangles, they have angles that are equal. Everybody's got a 59, everybody's got a 31, everybody's got a 90, but the sides are proportional. In other words, you can set up a proportion to be able to solve for the lengths of those missing sides. All right, let's get into our trig stuff. They're only introducing you to the first three trig functions, the ones that you're most familiar with, and that's sine, cosine, and tangent. So I think you probably remember in geometry looking at this as SOHCAHTOA. You can tell me when I see you if your geometry teacher talked about SOHCAHTOA. So I'm going to box this in because this is important. We're going to be using this over and over and over again. You really need to have a handle on it. When we get in the classroom, there's another way that I've taught kids how to remember it, but I don't want to put it on camera or on our video here. So remind me in the classroom that there's another way. So SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so you look at this triangle that we've got going on here, and we're going to talk about, well, what side's which, right? Here's my angle. This is a little theta. We saw that back in section 8.1. If I'm at this angle, the hypotenuse is always this guy that's the longest side. I'm going to call him a hype for hypotenuse. He's always across from the right angle. The other two options are opposite and adjacent. Opposite's the guy that's far, far away that doesn't touch it. Oh, and you can't see me on the screen. Let me move my papes. So opposite is the one far, far away. That's this guy. It doesn't touch the angle. It kind of closes the angle up. He's my opposite, OPP. And the side that actually touches the angle is one of the sides of the angle. That's my adjacent. And it's not an A for adjacent. It's just the letters they gave the triangle ABC. So here's how the trig functions actually go if I were to write them out. This is the abbreviation for sine. Sine is S-I-N-E. COS is the abbreviation for cosine. And tan is the abbreviation for tangent. And so if I want to figure out what the sine is, I have to take the opposite and divide it by the hypotenuse. That will give me the value. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Take whatever the adjacent side is, put it over the hypotenuse. And tangent is opposite over adjacent. So this one's opposite over adjacent. And so now we're going to practice with these. This symbol, this is a theta. That's just a name that they gave the angle. And we saw that back, I think, in section 8.1 that they did the same type of thing with thetas. But check out this first one. This one has a different symbol. This symbol is called alpha. Really, you can call the angle anything you want. It's just an angle. So sine of the angle, here's my alpha. Always got to make its location known. And before I even get into figuring out what the sine, cosine, and tangent are, I usually label up my triangle. So if this is where my angle is, I know 13 is my hypotenuse because it's the longest side. 5 is far, far away. It's the opposite. 12 touches it. It's adjacent. And once you have it labeled, then it's pretty easy. So you're looking at this, opposite over hypotenuse. Well, opposite is 5, hypotenuse is 13. This would be the fraction 5 over 13. Next one, cosine is adjacent over hypotenuse. So adjacent over hypotenuse is 12 over 13. And if I go for tangent, tangent is opposite over adjacent, 5 over 12. Done. That's it. You're just setting up the fractions. All right, last triangle on this page. This symbol represents beta. B-E-T-A, beta. Again, it's just a symbol that is representing the angle. So you check out where the angle is that they're talking about. Here's beta. I found you. Label up your triangle. 17's the hype. 15's furthest away. He's opposite. 8 touches it. It's adjacent. And then once you have those labeled and thought through, then the rest of this is pretty simple. So you've got sine is opposite over adjacent. We're still going back to our rules up here. Opposite is 15. Hypotenuse is 17. Next one is cosine adjacent over hypotenuse. So that's going to be 8 over 17. Tangent's opposite over adjacent. Opposite's 15. Adjacent is 8. And again, this should all be a reminder of things that you've seen in geometry, so I don't think there's anything too difficult today. All right, we're flipping. Next page. So find the missing side, find the missing angle. Here's where you need your calculator to be able to do this. We're going to set it up and do the same type of thing we were doing on the front side. So find the missing side. So I have 28 is right here. 28. That makes x my hypotenuse, and 22 touches it. That's the adjacent. They didn't tell me anything about the opposite side, so I'm not even going to label it. So the question is, which of our trig functions, now I'm going to just write it vertically because that's what the space provides here. SOHCAHTOA. Right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Based on what they gave me, I'm going to decide, am I using sine, cosine, or tangent to solve this out? And so, again, I don't do anything. If they didn't give me a number at the side, then I don't say what it is. I just leave it blank. So I have an adjacent and a hypotenuse. Adjacent hypotenuse means I'm going to use cosine. So I'm going to set it up, cosine. Do you know the angle? And the answer is yeah, it's 28. Of 28 degrees equals the adjacent, which is 22, over the hypotenuse, which is x. All right, here's where your handy-dandy calculator comes into play. So I have the graphing calculator, and the first thing that I want to do on my graphing calculator is check out what the mode is. So I'm going to hit, see the next to the second it says mode. If you have it turned on first, that helps. Okay. If you have one of the blue calculators, I think you can do the same type of thing in your mode. So this one is already highlighted in degrees. I know it's in degrees, which is perfect for what we need because our angle is in degrees. We're not in radians for this one. So 28 degrees. I want to make sure I'm in the right mode there. So I'm going to clear out of that. And I'm going to my home menu. And I want to know what the cosine of 28 degrees is. Now it's going to be some kind of a decimal of some sort. So I'm looking, I want cosine, and it has a cosine button right here. So I'm hitting cosine, and then it's like, well, what angle do you want to know the cosine of? And we say 28. Now, this calculator, you can close the parentheses. It doesn't really matter either way. This calculator will calculate it out. For the sake of these problems, we're going to be rounding quite a bit. Let's just try to go to 3 decimal places so that we're all talking the same language. If you use less decimal places, your answer is less accurate. And when we get into some of the word problems we're going to look at, we want to try to be as close as possible. So we're going to go with 3 decimal places. So this would be 0.883. Well, that's what this equals. 0.883 equals 22 over x. So I just got that right from the calculator, no issues there. Now here's the easiest way that I've seen over the years to be able to figure out, you're either going to be multiplying or you're going to be dividing when you go to solve for x. You're looking for what x is. The easiest way to do this is take that decimal point, put it over 1, just like you would a whole number, and then cross multiply it. So if I do that, then I have 0.883 times x, 0.883x. 1 times 22 is 22. And that sets it up for you pretty nicely, so you'll know how you're going to solve this out. So really what you want to do is take 22 and divide it by 0.883, and that's going to tell you what x actually is. So let's do that. If I take 22 divided by 0.883, I get 24.91. I'm looking at my answer key and I'm like, I'm not matching my answer key, so that's the pause. But I think that the mistake is on the answer key. I'm going with it. For whatever reason on the answer key, I have this listed as the hypotenuse and this is the adjacent, and that's not true. That is definitely not true. The hypotenuse is opposite the right angle. So I'm going with where we're at today. So 24 point, and we said 3 decimal places, 915. And that's how long that would be. And it kind of makes sense. Now, this should always make sense in your triangle, that if this side's 22, this one is a tad longer. It has to be because it's the hypotenuse, so 24.915 makes sense for that. It's kind of logic. You want to take a look at how logical that is in the midst. All right, finding missing angle. How about if you have an angle that's missing? Well, here's where the angle is. You still want to label up your sides as to who's the adjacent, opposite, or hypotenuse. So, and again, I'm only doing it for where they give me numbers. So this one, 12, is opposite. And the 20 is the hypotenuse. So I go to my little list at the side, who's involved with opposites and hypotenuses, and that would be sine. So I set it up, sine of x, my angle, equals the opposite, which is 12, over the hypotenuse, which is 20. So there's my setup for it. And so here's the story with this one. This one's just a little bit different. If I want to look for an angle, and I might change up my pen color here. If I want to look for an angle, this is only when you're looking for angles, you want the button on your calculator that's the inverse sine. It goes sine to the -1. All right, so let's see if we can find that. I think on those blue calculators, there's a little thing that says trig. And then if you press trig, you can get into, you'll have a choice for sine and then sine to the -1. On this calculator, it is, see how it's in yellow right here? Or orange or whatever that is. So in order to get to it, you have to do second and then press the sine button. And that'll get it for you. So that you see it's sine to the -1. And then all you need to do is put in your fraction, which is 12 divided by 20. And again, it doesn't, this calculator is kind if you put the parenthesis or not, but here it is. That's what the angle measurement would be. So remember, when you're finding angles, you need sine to the -1 or cosine to the, whatever trig function that you're looking for. It's that to the -1 power. So I have 36.87, 8699, however you want to do that. I have 36, I'll put it below, 36.87, I'm going to say, degrees. So the only difference really, I mean, it's different buttons that you're using, but remember, for finding angles, it's the little -1 doohickey has to be there, where if you have the angle, you don't have to do that. Okay, couple of word problem type things, and then we'll do a couple examples, a couple problems from the practice. So an airplane takes off. Are we ready to do that yet? No, we're solving this triangle. Hang on a second. I thought this triangle was part of the problem, but it isn't. All right, here we go. Solve. That's all they told you. Solve. That means they wanted you to find all the angles and all the sides. That's what that means. Solve means find all angles and sides. Find all angles and sides. Well, the easiest thing if they've given you an angle is to figure out that last missing angle. We saw that on the front side. We know that 180 degrees minus the 90-degree right angle minus 62 degrees is going to give us the missing angle up here, that's angle R. And so if I do that subtraction, I get 28 degrees. That's angle R. Now they use capital letters to designate the angles, and they use small lowercase letters to designate sides. So right now you can see these are all capital letters because they're talking about what the angles are. All right, so this guy is 28 degrees. I can put it in there. And they gave me 12, which is the hypotenuse. But I need to figure out what the shorter side is and the longer side is. And you notice I'm using long and short rather than adjacent and opposite, because that depends on what angle you're looking at. If I'm at 62 degrees, and that's probably the one that I'm going to use, is the one. I usually use the one they gave me just in case I made a mistake in the subtraction like I did in the front, on the front one. If I use this angle and I subtracted wrong to get it, then all my answers are going to be wrong. So I usually go back to the one that they gave me just to play safe. If I'm at this angle, then this would be my opposite side, and this would be my adjacent side. However, if I were up here at this angle, that switches. This would be my opposite, and that would be my adjacent. So it depends which angle that you're looking at, and you can use either one. They didn't tell you which way to go. You can use either one, whatever you want. So if I want to find, and you have to do this one at a time. These are going to be two separate steps. You can't find them both at the same time. So it's going to be one, we're going to do one process, then we're going to do another process to figure out the other side. If I want the opposite side, I only know the hypotenuse. So that means I have opposite and hypotenuse. I'm using sine. So here it goes. The sine of 62 degrees equals my angle. Opposite, which is what I'm looking for, x, over my hypotenuse, which is 12. So we saw this was back in the find the missing side example up above, but I want to go to my calculator and I want to know what the regular old sine of 62 is. So I'm going to hit sine and then 62, and it tells me 0.883. So this is 0.883 equals x over 12. And then remember I said to you the easiest thing to do is to put this over 1 and cross multiply. 1 times x is x. 0.883 times 12, I don't know, let me try it. 10.596. So that's how big the side would be from R to E. RE. Remember that little segment sign from back again in the day of geometry? All right, so now I know what this guy is. Now I have two choices to be able to find the adjacent side. One choice would be to use the adjacent, actually I have several choices. Adjacent and hypotenuse, that's probably the way that we'll go. Let me do that and then I'll come back and give you some other options. This one, adjacent and hypotenuse, is cosine. So the cosine of 62 degrees is the adjacent x over 12. So I go to my calculator and I say, all right, what is the cosine of 62? It says 0.469. 0.469 equals x over 12. Put the 0.469 over 1. Cross multiply. 1 times x is x. 12 times 0.469. 5.628. That's how big that missing side would be. And that is side D to E. Does that make sense if I put this back in here? 10.5-ish, 5.6-ish, and it does make a whole lot of sense. Another rule for triangles is the larger side has to be opposite the larger angle. So it should be, if this is 62, this side here should be bigger than this guy that's 28 and the adjacent side that's opposite it. So it kind of has to all fit into place. One of the things we could have done at the point where we knew what two of the sides were, you can go back and use Pythagorean theorem. Remember him? A squared plus b squared equals c squared. You could definitely go back and use Pythagorean theorem to find that third side. When you know two sides and you're looking for the third side, Pythagorean theorem would also come into play. And the other thing is, if we knew, since we knew the opposite side, you could also have done tangent, opposite and adjacent. You could also have used the tangent function for those. So there's a couple different options, but we'll see as we go along. We'll kind of pick and choose. They would all get you the same answer in the end. So your methodology of how you go about it is fine. You can choose lots of different things, but in the end we should have the same answers no matter which road you took. Okay, so here's my airplane. Takes off with an angle of elevation and raises to an altitude of 1,500 feet. How far is the plane from the airport via the ground distance? Now, the best part of these word problems is trying to draw the picture. I say that kind of funny and sarcastic at the same time. If I were to do that, I'm at the ground here, right? The airplane takes off, goes in the air, gets to an altitude, that's the tallness of it, an altitude of 1,500 feet. How far is the plane from the airport via ground distance? So this is where our x is. And by the way, they forgot to tell you what the angle is. An elevation of, they forgot the 12 degrees. So plug that 12 degrees in there. Now, angles of elevation are always when you're looking up at something. So you're looking up at this. This would be the angle of elevation. From the ground to the angle, it's an upward type of situation. This is what's 12 degrees. And then it's just like the rest of the problems we've done. Once you have the picture, the question is, what trig function are you going to use to be able to solve it? So if this is 12 degrees, this 1,500 is your opposite. The x is the adjacent. We technically have a right triangle here, and the hypotenuse they didn't tell us anything about, and we're not going to worry about it. We just want the trig function that deals with opposites and adjacents, and that would be tangent. Again, from my TOA. All right, so the tangent of 12 degrees equals the opposite, which is 1,500, over the adjacent, which is x. Do you remember what to do next? Handy dandy calculator. We want to know what the tangent of 12 is. Tangent 12. 0.213, we're going to say. Again, a rounding thing. 0.213 equals 1,500 over x. Put it over 1. Cross multiply. This one's not going to be as easy. I've got a couple steps to get to the answer, but I have, I'll go over here, 0.213x equals 1 times 1,500. So I have to go to my calculator and I have to divide that to be able to calculate out what this is going to be. So back to the calc. 1,500 divided by 0.213. And I get 7,042. 7,042.25. X equals 7,042. I guess we said we'd go 3 decimal places, so 0.254. If there are units in the problem, then you want to put units on your answer. So my look here is, it was in feet, so this would be how many feet is the ground distance down here at the bottom. 7,042.254. Most kids don't get too confused by this angle of elevation thing, but the angle of depression tends to get peeps. So let me show you what they're talking about for this one, the last example problem. Angle of depression. Mr. Bruce looks out his window with an angle of depression of 32 degrees to see 2 kids fighting. Oh my. He decides to break up the fight if it's less than 50 meters away. I guess because 51 meters would be way too far for him to go. If his window is 28 meters from the ground, will he break up the fight? All right. So let's draw the situation. Sometimes it's easiest to see it from a picture. Oh, I forgot to draw my airplane on the last one, huh? How do you draw an airplane? Kind of looks like a fish. We'll have to see when we're in class if you can draw a better airplane. Get me beat. This one's in a house or something like that. He's in it. He's inside. And he is looking out the window. Here's his window. Mr. Bruce. There he is. He's standing on the ledge, I guess. The way that I have it drawn. He sees two boys fighting over here. Why does he have to make the problem with them fighting? Can't they just be shaking hands or something? All right, so looking at the rest of the problem, I know that I've got two boys fighting. I know he's looking out the window. Looks out his window with an angle of depression of 32 degrees. Here's the part that's really confusing for most kids. Angles of depression have to come off the horizontal. In other words, the angle of depression, let me show you and then I'll talk more about it. The angle of depression is this one. It's coming down from the horizontal. That's an angle of depression. Where this one's going upward, this one's coming down. Angle of depression, right? Of 32 degrees. The question is, how far away is it from the bottom of the building? Because if it's more than 50 meters, he's not going to break it up. And his window is 20 meters from the ground, or 28 meters. So this is 28, the height of this. The window is, there you go, 28 meters. Now let's take a trick from geometry. Because, well, there's two ways you could do this. You could close this in like it were a rectangle and make this 28 and then solve the triangle that way and make the X at the top. I tend to just remember this one rule from geometry. These are parallel lines. When you take it from the horizontal to the ground, they're parallel lines. And there's a relationship between this 32-degree angle and this angle that's inside my triangle that says that they are going to be equal to one another. They are alternate interior angles, and since they are alternate interior angles for two parallel lines, this means parallel, then they're going to be equal to one another. And so now I have my triangle down here, and that's the one that I'm going to work with. So my angles here, 28 would be opposite, X would be adjacent. And so which trig function do you want if you are opposite and adjacenting and you say tangent? Tangent of 32 degrees equals 28 over X. And so you got your setup, you go into your calculator, and you're going to figure out the tangent of 32. 0.625. Here it is. 0.625 equals 28 over X. Put it over 1. Cross multiply. 0.625X is 28. And then we divide. Again, calculator, 28 divided by 0.625, and I get 44.8. What are my units? Units are meters. Is he going to break up the fight? So that's really, you always have to go back and make sure you answer the question, because just because it's 44.8, that's my mathematical answer. We didn't actually answer the question. They do this on the SATs all the time. So if his window is 28 meters from the ground, will he break up the fight? And the answer is yes. He will break up the fight. Break up the fight. Because it's less than the 50 meters that you had. All right, I'm going to pick and choose just a few, and then that's it. So that's all of the note parts. We're going to go to the practice problems, and I kind of picked one from each type of thing. So the first one is number 1 that we're going to look at. Number 1 got hole punched off, but number 1's the first guy. And I wanted to show you this because, again, it changes, what you're looking for changes based off of which angle you're starting at. So this one's the sine of A, of alpha, I'm sorry, at alpha. If I'm over here at alpha, I'm going to label my triangle for alpha. I have 5 would be opposite. 13 is always the hypotenuse no matter what. And that makes 12 the adjacent. If I think SOHCAHTOA, right, put my little SOHCAHTOA here at the top of the page. If I think SOHCAHTOA, sine is opposite over hypotenuse. Opposite is 5. Hypotenuse is 13. But you'll notice the second question asked you, what's the tangent at beta? Well, beta changes things up. Now, I talked about this a few minutes ago. Here's my beta angle. That makes 12 my opposite, and it makes 5 my adjacent. Far, far away is 12, touches it is 5. So it changes according to which angle you're looking at. So if I'm at beta, tangent is opposite over adjacent. This guy's going to be 12 over 5. So just be careful of that. You got to watch what angle they're giving you. In number 2, you're using theta for both of them. In number 3, they change it up. Sometimes you're using alpha, sometimes you're looking from beta. So just beware of those. All right, next one I chose was number 6 because they didn't give you a picture. And I thought that you might look at that and go, what? So you have a triangle DEF. Now it does not matter, and D is the right angle though. So if I draw my picture, I'm going to actually draw it in this box just because that'll give me space to solve out the question. I have a right triangle. D is my right angle. Find the measure of angle E. Oh, find F actually, little f. Now notice how now they're using the small letters and the big letters. So I want to know what little f and if little e is 4 and angle E is 16. So I know I have a triangle with a DE and an F, triangle DEF. It doesn't matter if you make this guy your E or your F. The other one's going to be the opposite. You can flip-flop these if you want. It doesn't make a difference. Now that means that if this is capital D, the side opposite it is little d. If this is capital E, the side opposite it is little e. And if this is capital F for my angle, the side opposite is little f. So there's the drawing that goes with that particular thing. And that's going to be the same thing. It's going to be the same drawing for numbers 9 and 12. So however you make your first one, you can make the other ones exactly the same. I know that angle E is 16, and I know that little e is 4. The question is asking me, what is little f? Well, little f would be this guy. All right, so now you've got, it takes you a while for this one. I have this angle is 16. Let me label my triangle. That makes E opposite, and it makes F adjacent, and D is my hypotenuse. But I don't know anything about D, so I'm not going to use it. That's not going to matter. So what I do know something about is little e, the opposite side, and I'm looking for the adjacent side. So I've got to think of which trig function deals with opposites and adjacents. That would be tangent. So I set it up. Tangent of 16 degrees equals the opposite, which is 4, over the adjacent, which is little f, which is what I want. And so now it's set up like all the other problems we've been doing today. If I figure out what the tangent of 16 is, 0.287, 0.287, I'm hoping my dog is not going to start barking. I'm trying to tell him no. Put the 0.287 over 1 and cross multiply. You get 0.287 little f equals 1 times 4 is 4. And so I am going to divide them. I get 4 divided by 0.287, and that gives me 13.937. Little f is 13.937. Okay. The next one I chose was number 11. Number 11, Here it is. This one, the directions say solve the triangle. Remember, that means you have to find all the angles and all the sides. So, why do I feel like we've done 28 degrees a million times today? But we have. If I want to know the missing angle, I have 90 and 28. So I'm going to find the missing angle first because that's easiest. 180 minus 90 minus 28. And you say, oh, that's 62. There you go. That's angle A. 62, not 5. 62 degrees. All right, I guess we can label this up with our little letters, right? So if I look at the other sides, if this is C, this is little c. And if this is B, this is little b over here, just because I know I need to find, I know what little a is. Little a is 5. I'm looking for little b, I'm looking for little c. And again, I usually go back and use my 28-degree angle, the angle they gave me. So if that's the case, then my sides are going to be, this guy's going to be, I'm going to label it right here, this is my hypotenuse. This is my adjacent. This is my opposite. Let's go for finding B first. The only thing I know is the adjacent side. So I need the trig function that deals with opposites and adjacents. We've been seeing him a lot today. He is a tangent. Tangent of 28 degrees equals the opposite, which is little b, over the adjacent, which is 5. So I go to my handy dandy calculator, and the tangent of 28 degrees, 0.532. 0.532 equals b over 5. Put it over 1. This one's easy. I get b, 1 times b, and 5 times 0.532. 5 times 0.532 gives me 2.66. All right, now I'm going for C. Again, I can use Pythagorean theorem at this point. I can pretty much use almost anything that deals with the hypotenuse. I'm going to go, because this is the hypotenuse, I'm just going to go with, I don't know, do you want to use Pythagorean theorem for kicks and giggles? If I know this side over here was 2.66. Here's how it would look, and I know this side's 5. I'm looking for the missing hypotenuse. So, remember, a squared plus b squared equals c squared. A is 5, 5 squared. B we just found, 2.66 squared, equals c squared. So I'd have 25 plus 2.66 squared, 7.076 equals my c squared. So I'm going to take that value and I'm going to add 25 to it. And then I'm going to take the square root of that, right? Because I have c squared. So I want to know the square root of that. Some of you have a square root, but I do too. I have a square root. 32.0756. 5.66. That's my answer for C. So C equals 5.66. And you have just solved that triangle for all of the sides and all of the angles. Takes a little doing. They're a little bit more work because you've got like 3 problems in once. We had to figure out one of the angles, and then we had to figure out 2 of the different sides. You could use trig to figure this out. You could definitely use one of your sine, cosines, or tangents to get this. You'd get an equivalent answer. So I just took you down the road of a Pythagorean theorem just to show you the difference. All right, last 2. Here we go. Last 2. Number 15. And I chose these because they kind of add a little bit of a different flavor than the 2 word problems we did previously. So, closed circuit TV camera is mounted on a wall 7.4 feet above a security desk. Here's the desk. Here's the camera. That means that this must be 7.4 feet. It's used to view the entrance door 9.3 feet from the desk. Here's the desk. Here's the door. The distance between them is 9.3, so it has to be this distance down here between the desk and the door. This is a 9.3. Find the angle of depression from the camera lens to the entrance door. Now the angle of depression, remember we talked about that, comes off of this horizontal. He's the guy that I'm trying to find. But he's not part of my triangle that I've created. So I have to think about this a little bit. If I take the angle that would be equivalent to it, alternate interior angles, it would be this guy here. I'm just going to put my X in there for my, that's what I'm looking for. I want to know what that angle is. All right, now I got the setup. Now I'm going to label my sides. So if I'm at this angle, 7.4 is opposite, far, far away. 9.3 is adjacent because it touches it. And you'll see a lot of these word problems deal with tangent. For whatever reason, it always comes out tangent. But that's what we got. We got opposite and an adjacent. So I know the tangent of my angle, X, is opposite 7.4 over adjacent of 9.3. Now, do you remember how to do this? We only did one of these previously. But when you're looking for the angle, they're the ones that you have to put your calculator with the -1 guy. (7.4 over 9.3). So let me show you again on the calc how that works. Okay, here's my calc. So I want the tangent to the -1 guy. So second tangent. And then all I have to do, I probably should write this a little differently. Hang on a second. Tangent to the -1 of 7.4 over 9.3 equals X. And the question is, what's the X? So when I'm putting it in the calculator, I'm putting in literally 7.4 divided by 9.3, and it tells me exactly what the angle is. It should be 38.509. 38.509 degrees. That's that angle of depression. Okay. All right, next one, and this last one, 18. This adds in a little extra doohickey in the midst of it, which is why I chose this one. This one has the extension ladder on top of a 6-foot high hook and ladder truck is 150 feet long. The extension ladder is 150 feet long. So here's my extension ladder. This is 150 feet. On top of a 6-foot high hook. Now, here's where the bottom of the ladder is, right? The bottom of the ladder is down here. The top of the ladder is up here, but it's not to the ground, and your triangle goes to the ground. This little piece here is the 6 foot that they're talking about. The ladder is on the back of the truck, and it sits 6 feet off the ground. That's this part here. If the angle of elevation of the ladder is 70 degrees, they have that in there already. To what height on the building will the ladder reach? You're looking for X. All right, so if I take this triangle and I look at the triangle, I don't know if this is going to help with my, I can figure out, this is still the same right triangle with the same dimensions. I can figure out what that triangle is, get what X is, and then what am I going to do to figure out what height on the building will the ladder reach? I just need to add the 6 onto it. So I'm going to ignore the 6 for now. That's going to come into play at the end. And so I have here 70 degrees. This one's opposite. This one's hypotenuse. And so I'm using sine. So the sine of 70 degrees equals X over 150, opposite over hypotenuse. And so I do my same work that I've been doing. I go to my calculator. I find the sine of 70. 0.9, well, that one rounds, I guess 0.94. So I've got 0.94 equals X over 150. And so I'm going to put that over 1, cross multiply. This one is just a multiply thing. So I times it by 150, and I get 140.954. 140.954. But that's only stopping right here. And I have an extra 6 feet that I need to add to that. And so my final best answer to answer their question of how high on the building can the ladder reach, it's going to be, I'll put it up here and circle it, 146.954 feet. And so that's my final answer. All right, that is section 8.4. I will see you in class. Shoot me an email if you need me.